Welcome back to Concepts in Arithmetic. We've completed our work on the 4 algorithms for the operations of arithmetic, and we're going to move on to pre-algebra. And this is designed to help students make that transition from arithmetic to algebra and show that algebra naturally builds on the concepts that our elementary students already know from arithmetic. So the most obvious difference between arithmetic and algebra is that algebra involves the use of letters. So why use letters to represent numbers at all? What's the point? Well, there are several reasons. Firstly, it could be that the number is unknown. Okay, now we've already dealt with unknown numbers before, but we just sort of left a blank. Okay, but is there really any difference between these 3 expressions? Okay, 5 plus blank equals 13. 5 plus question mark equals 13. 5 plus x equals 13. They all convey the same idea. So if an elementary student can understand this, they can also understand this. Okay, and these two here are related. We might want to show a relationship that holds for all numbers. Or we might want to demonstrate a calculation that applies to an entire class of numbers. So we could use letters to help us there. So we'll see examples of all 3 of these ideas here in this video. Okay, so looks like I'm in the way here. Let me scoot over to there. Okay, so as far as representing unknown numbers with letters, well, let's think about our teacher solutions. Let's think about these word problems here. Okay, so let's look at an example here. Kate bought 3 books and a magazine. The total cost was $25. The magazine cost twice as much as a book. And the question we're trying to answer is, what is the cost of a book? So we might represent it with this bar diagram. 3 books, 1, 2, 3. 1 magazine. Notice the bar for the magazine is twice as long as the bar for the book, leaving us with a total of 5 bars. So that's 5 units corresponding to $25. That means each unit costs $5. Each unit represents $5. Therefore, since a book is represented by 1 unit, that means the book costs $5. Okay, very easy. Let me scoot up here. Okay, so we could do the problem also using algebra. Okay, so the cost of a book I'll represent by B dollars. Cost of a magazine would be 2B dollars, right? They state that in the problem. The magazine costs twice as much as a book. Okay, so whatever the cost of the book is, you multiply that by 2, you get the cost of the magazine. So the total cost for Kate, well, she bought 3 books, which would cost a total of $3B plus a magazine, which is 2B. So we have this equation here, 3B plus 2B equals $25. For 5B equals 25. B equals 5, dividing both sides. Either way, we arrive at the conclusion that a book costs $5. Okay, and I would note that in this example, the numbers involved were pretty small, so there's no real advantage to using the algebra compared to the bar diagram. However, when the numbers get bigger, the algebra method is a lot simpler. Okay, so algebra is better for problems with larger numbers. So let's do a quick example of something like that. Okay, so let's say a farmer has, can I get up here in the corner? Am I out of the way up in the corner there? Okay, I am now. Okay, so a farmer has 33 times as many hens as roosters. So he's got hens and he's got roosters. Way more hens, 33 times as many hens as roosters. He has 442 chickens altogether. So how many roosters does he have? Let X be the number of roosters. Okay, so X is going to be the number of roosters. Then 33X is the number of hens. Thus, if I count my hens and my roosters together, I should get 442. Okay, well, if I have 33 plus an additional X, that would be 34 of those. Okay, now I got to do my computation. Let me see. Looks like I'm going to need to do this by long division here. I'm going to have to divide there. 34 into 44 goes one time. 102. Let me see. What I would estimate that maybe with a 30 going into 100 3 times. Okay, so 90 plus 12. Okay, 102. Goes in evenly. All right. So that tells me that X would equal 13, and that actually that answers my question. It says how many roosters does he have? Question mark. And the farmer has 13 roosters. Okay, so a bar diagram for a situation like this would be not very helpful because you'd have to draw 33 segments in that top bar, right? If we were doing it like we did the book problem. So probably simpler to just do it with letters to stand for the unknown number of roosters that we wanted to find. Okay. Let me look at a different way of thinking about using letters for numbers, because we did a whole list here, right? We had several reasons why we would want to use letters to represent numbers. One being the number is unknown, like in word problems. To show a relationship that holds for all numbers, or to demonstrate a calculation that applies to a whole class of numbers. So let's imagine this here. So let's start with the fact that we'll just say composition books cost $3 each. Let me make a little table like this. So in this column I will have the number of books I'm buying, and over here I will have the cost. Okay, so 2 books, that would cost $6. 3 books, $9. 5 books, $15. 12 books, $36. And of course the idea is that whatever value I have over here, I take that number and multiply it by 3 to get the cost. So that's a calculation that I would do no matter what the number of books is. Whatever the number of books I purchase is, I take that number, multiply it by 3 to get the cost. So if I bought X of these, I would just do 3X. Okay, so that's a way to demonstrate a calculation that would apply to a whole class of numbers. No matter how many books I buy, I can get my cost by applying that rule. Okay, another one kind of like that. Oh gosh, let me tuck myself over here. Okay, another calculation kind of like that. Okay, so Miss Jackson bought T textbooks for $12 each and 2 teacher's guides for $8 each. So let's look at something here. Let's look at an expression involving T that gives the total cost. Well, the textbooks cost $12 each, so no matter how many you buy, you take that number, multiply it by 12. So you have 12T. That's the cost from your textbooks. You've also got the teacher's guides to throw in there, but it says right here she bought 2 of those. They each cost $8. So her total cost would be 12T plus 16. And let's look at this here. Let's look at the cost if she buys 7 textbooks. So the cost if you buy 7 textbooks. Well, we would do 12 times 7 plus 16. Okay, 12 times 7 is 84. Oh, okay, it's an even $100. Nice. Okay. So the cost for the 12 textbooks is $100. Okay, so a couple of examples of using letters to help us demonstrate a calculation that would apply no matter what this number is. Okay, it shows us a procedure. It gives us a very quick way to write that down. All right. I do want to make a note about when we are using these letters, we've got to be a little bit careful about how we write things down. Okay, typically when we're dealing with word problems especially, we're talking about things that our author refers to as quantities. A quantity involves both a number and a unit. So you've got to be a little careful. So I'm going to come back to this in just a sec. But in word problems, your letter should represent a number, and the meaning should be clearly written out. So these up here, these would be acceptable ways to talk about something. Let M be Maria's height in inches. All right, this is also good. Maria's height, that's M inches. This is not good. Let M equal Maria's height. Okay, M is supposed to be a number. Maria's height will have different numbers depending on how you measure it. Are you talking about inches or are you talking about centimeters? Because the same height will have a certain number of inches. For example, my height is, oh gosh, what am I? 70 inches, but I'm 180 centimeters. Okay, so you got to specify the quantity to tell the value that this number is going to have. And this is also terrible. M equals Maria. That's no good. This is saying Maria is the same as a number. Well, we don't want that, right? The letter is supposed to stand for a number. And we should clearly write out what that number is. Okay, and up here, talking about quantities again, he drank X glasses of water. That's the number, and that's the unit, X glasses. X is our number, whatever it is. Glasses is the unit. He drank X glasses of water. He drank X water, that's no good. To say he drank 3 water, what the hell does that mean? Okay, that's not a thing. Okay, so when you are using letters in pre-algebra, make a habit out of specifying in writing what the letter is standing for. The letter's got to stand for a number, so you've got to specify the units as well.